Hello everybody, Sir Beaton here and welcome back to another past paper practice video. In this video we will be looking at a matrix question, so let's head straight into it. So the question says three matrices are given as follows, and we have the matrix P being -1, 2, 0, 5 and Q being AB and R being 11, 15. Using a calculation to support your answer, explain whether matrix P is a singular or non-singular matrix. So in order for matrix P to be singular, then matrix P must have a determinant of 0. So we find the determinant of P, and if it is 0, that means it's singular. So let's go. So determinant will be multiply these two, -1 multiplied by 5, subtract 2 multiplied by 0. You can also see this will not be 0. So -1 times 5 would be -5. Subtract 2 times 0 is 0. Hence this will be a -5. So because this is not equal to 0, P is a non-singular matrix. And the reason being, because the determinant of P is not equal to 0. All right, so let's move on to the next question. Next question says, three matrices are given as follows, and we have the same three matrices. So given that PQ is equal to R, determine the values of A and B. So we see PQ is equal to R. So we know it's matrix P times Q. So we know matrix P would be -1, 2, 0, 5 times matrix Q, which is A, B, and that would be equal to R, which is 11, 15. And they want us to find A, B. So we need to take over this here to this side, and that will work out, and we work it out, we'll get the value of A and B. So when we take over this, this will become the inverse of what it was over there. So I'll find the inverse right to the top here to save some space. So the inverse is 1 over the determinant multiplied by the adjoint. So we already found the determinant just in this question. Determinant was -5. So determinant, so it's 1 over -5 multiplied by the adjoint. So we switch these two. So this will be 5, -1. And we flip the signs of these two. So this will be -2, 0. And we don't want to distribute this. You want to leave this just as this. It's easier to multiply that way. So this will be, so AB would be equal to, so remember we're putting this in front of this. So this will be 1 over -5 multiplied by 5, -2, 0, -1 multiplied by 11, 15. So it's row by column. So what we'll have, so we'll have 1 over -5. So it's row by column. So it's 5 multiplied by 11 plus -2 multiplied by 15. Then it's the other row by the same column. So it's 0 multiplied by 11 plus -1 multiplied by 15. Hence this will be 1 over -5. So 5 times 11 will be 55 plus -2 times 15 would be -30. And 0 times 11 would be 0 plus -1 times 15 would be -15. Hence I'll work this out to the top here. So I'll have 1 over -5. This will be multiplied by, so 55 plus a -30 will be the same as 55 minus 30, which will give me 25. And 0 plus -15 will be the same as 0 minus 15, which would be a -15. So 1 over -5 multiplied by 25 would give me a 25 over a -5. And 1 over -5 multiplied by -15 will give me a -15 over a -5. Hence this will be 25 divided by -5 would be negative 5. Two negatives will cancel out. 15 divided by 5 would give me 3. Hence, I can say, therefore, this is equal to AB, because that's what we were finding all along. So, therefore, we can say A is equal to negative 5 and B is equal to 3. And that would be our answer for A and B. So the next question says, state the reasons why the matrix product QP is not possible. So we see QP. So we see Q is we have 1, 2, we have a 2 by 1. So this is a 2 by 1. And we see P is 2 by 2. So they want QP, so it's Q, so this matrix, which is a 2 by 1, multiplied by a 2 by 2 matrix. And as you can see, these two, they are not the same, hence they are not compatible. So we can say the reason would be the number So the number of columns in matrix Q is not equal to the number of rows in matrix P. Hence, they are not compatible for multiplication. And this test is simply done by just putting on the two orders of the matrix next to each other. And as long as the inner ones are not the same, they are not compatible, or the multiplication is not possible. So with that, this has brought me to the end of this video, and I trust that you have a good understanding of how to answer these questions, and I want you to continue practicing. Practice makes perfect. So until then, I'll see you in the next video, in which I'll be looking at some more past paper questions. Until then, take care.